So 36 or 34, my fault. 34 says to find the average rate of change for the function g of x equals negative 4x squared plus 3x minus 4 between the points negative 1 and 3. Okay? So the first thing that you need to remember is that in order to find the average rate of change, okay, alright, so to find the average rate of change, you must remember average rate of change is equal to f of b minus f of a divided by b minus a. Alright, so f of b is going to be f of 3 minus f of negative 1 divided by 3 minus 1. Okay? So, that's what, so it might have been f of y2 minus, no, it'd be f of x2 minus f of x1, and the x2 minus x1. So you can put, it's the same thing. Alright. You y2 minus y1? I can't. I'm putting it this way though, that way, because this is the way that you're gonna, I want you to get used to seeing it this way for your next math class, especially if you calculus, because that's the way we're gonna write a lot of stuff, is certain things. Like you'll see this next, you'll see the exact same thing next year if you calculus, but it'll just be kind of different. So it's just, I want you to get used to the notation. So f of 3, again, all you're doing here is you are plugging 3 into that function. Alright, so you're going to get f of 3, which is equal to, or not, well, it's actually g of 3, f and g, whatever, it doesn't matter. It's going to be negative 31 minus, now plug negative 1 into that, I get negative 11. Divided by 3 minus 1, which is 2. Negative 31 minus negative 11 is going to be negative 20. Divided by 2, which is going to be equal to, that's actually 3 minus negative 1. So this is actually 4. That's negative 5. This is 3 minus negative 1. You get it right? Alright. Questions about that? 36 is going to be essentially the same thing with a different function and a different, any question about this? No. 36 is f of x is equal to 3x cubed minus 2x squared plus 6, and it is over the interval 2 to 6. Okay, again, average rate of change is equal to this. Okay, so we have f of b, which is going to be, in this case, f of 6 minus f of 2 divided by 6 minus 2. Okay, that's equal to 582 minus 22 divided by 4, which is going to be equal to 560 divided by 4, equal to 140. Okay. Questions about that? Okay. So, the next problem. Now, what you see a lot of times is when you're talking about average rate of change, especially in calculus, this is going to stick around with a lot in calculus, is the relationship between velocity, position, and acceleration. And position and distance are synonymous. All right? Is being able to read a graph and also be able to figure out things about those, about what's going on in this scenario. Okay? So what we have says use the graph to complete the following. So the first thing it says is find the average rate of change between 5 and 15, 15 and 20, and 20 and 45. So we have 5 and 15, 15, 25, or 20, we have 20 and 45. Okay, so again, this is average rate of change. Actually 25 and 45. So again, we know average rate of change is just going to be f of b minus f of a divided by b minus a. So this first one would be f of 15 minus f of 5 divided by 15 minus 5. Okay, so what you have to do is you have to come over here. F of 15 would be 55. F of 5 would be 5. So this is equal to 55 minus 5 divided by 15 minus 5, which is going to be equal to 50 divided by 10, which is going to be equal to 5. Speed is meters per second. Okay. So again, that's just average rate of change again. But instead of plugging something into the formula or into a function, we're using a graph. All right. Next would be we have f of 20 minus f of 15 divided by 20 minus 15 is going to be 5. Okay. So f of 20 is going to be, you look at the graph, is 70. F of 15 was 55, so that's 15. 70 minus 55 is 15. 15 divided by 5 is going to be 3 meters per second. It's important that you label this stuff. When it does give you a label for something, when you're talking about speed, you do want to make sure you're labeling this stuff. Okay. And the third one says f of 45 minus f of 25 divided by 45 minus 25 is 20. F of 45 is going to be 85. F of 25 is going to be 75. So 85 minus 75 is going to be 10. 10 divided by 20 is going to be 1/2 meter per second. Okay, so we have the average rate of change, the average rate of speed, right? The average speed over those time intervals. Between 5 and 15 seconds, it is 5 meters per second. Between 15 and 20 seconds, it is 3 meters per second. Between 25 and 45 seconds, it is 1/2 meter per second. Questions about that? Next says compare and contrast the nature of the speed of the object over these time intervals. Okay? Okay. What is happening to the speed as more and more time passes? Decreasing. Alright? It goes from between here and here, 5 meters per second, between here and here, 3 meters per second, and between here and here, only half a meter per second. So the speed is slowing down. That's all that part B is asking. Okay? What can we tell about the speed as the time is changing? The final question, part C, says, what conclusions can you make about the magnitude of the rate of change, the steepness of the graph, and the nature of the function? So there's a couple things here. The first thing says, what conclusions can you make about the magnitude of the rate of change and the steepness of the graph? The steeper the graph, the greater the rate of change. Does that make sense? Because just think of it, you're covering a large distance in a very short amount of time. So the steeper your graph is, the greater the rate of change. The greater the rate of change, the steeper the graph. It also says, what about the nature of the function? Nature of the function meaning is it increasing or decreasing? So this speed is positive, correct? Therefore, this function is increasing. Even though the speed is decreasing, the function is still increasing. And that's a very big connection, a very big turn your music off at one. You're very I was about to go to the door and stand it right in. Well, I don't know what you're doing. Here's how much I care about you. Because that goes to the internet, but I do it. Alright. So that's all it's asking is it wants you to really understand that when your rate of change is positive, your function's increasing. Alright? If your rate of change is negative, what do you think that would mean about your function? Decreasing. Okay? Again, that's very big, it's a very big concept in calculus. And your next math class, you're going into college next year. Okay? Questions about that? That's number 49. Okay. No question about that. This is what we're going to do today. Alright? I always find it a little bit challenging to come up with a way that's beneficial for you guys to review. Alright? So what I think is most beneficial is if I give you guys, and to be honest, there's 18 problems that I have to review. Okay? To be 100% honest, it's what would have been your homework. Because I was like, well, I don't want them to go home, do the homework, have questions on it, and not really get questions answered. Okay? So what we're going to do is, you guys are going to get the 18 problems. You're working on them. To be 100% honest, if you were working, like trying to get this stuff done, and you know what you're doing, there should be no reason that you shouldn't be able to have these problems done by 2 o'clock. At 2 o'clock, what I want to do is, hopefully people are back, there are about 12 of you in here, maybe 11, I'm not sure what the numbers are, and I'm not sure if everyone's here today, because everyone left that day, at that point in time, every one of you has to volunteer to present at least one problem. And I have the problems on paper back there along the board. So you would go back there, you would write up your answer. So in fact, what we'll do right now is we're just going to, I'm going to pass out the review. Okay? We're just going to you're gonna go through this at 2 o'clock, you're gonna pick one, you're gonna go up to the board, you're gonna write your answers. You'll sit back down, and then you'll present your answer to the rest of the class. Okay? The only one, so that's it. So, there is one multiple choice question on here. The multiple choice question, you do have to explain if you choose to put that one on the board. Okay? So, again, what I'm gonna do, I'm gonna give you guys till 2 o'clock to work on these problems, and we'll work on them together. Okay? Whatever you don't get done, that's homework. Okay? Whatever you do get done, you are going to be required to at least present one of these problems to the class.
Can you explain how we got the answer and stuff like that?
Yeah, I mean, for the most part, it'll be easy. Like, if it asks you, is this a function, you have to write your explanation and then the other thing more.
Okay.
So, it's gonna be a pretty, this test should not be terribly hard. Well, not this, test on Wednesday. Yes, this is your guys', this is your review. Okay, you're not turning this in. This is your review to take home with you and to review. But we're working on them right now. Maybe you guys till 2 o'clock.